Now the question is, see here, we are given a1, a2, an, some fixed real numbers, and relation a function is defined on them as fx equal to x minus a1, x minus a2, and up to x minus an. We have to find out limit x tends to a1 fx. Firstly, we have to find out limit x tends to a1 fx. Now, if we look at the function, we know that whenever we apply the limit should be in its, the function should be in its most simplified form. Can we further simplify this? No, because they are in the factors form, है ना? Factors वाली जो form होती है वो most simplified form होती है. No factor can be cancelled out, nothing can be done with this function. So we can apply the limit. And applying the limit means x tends to a1. So we can put a1 in place of x. So let's put a1 in place of x. So if we are putting a1 in place of x, we get the answer. What is the answer? 0, because this term is a1 minus, right? So ये तो simply आ गया, x tends to a1 fx is 0. Next we have to find out for some a which is not equal to a1, a2, an, any other term we are given as a, we have to compute the limit x tends to a fx. So this was the first part of the question, and second part is we have to find out the limit x tends to a fx. Again, the function is in its most simplified form. We have to find out the limit x tends to a. So x tends to a means we will put a in place of x. Wherever there is x, we have to put a. So let's put a1. A minus a1, a minus a2, a1 is not, a minus a2. So this is, further we cannot do anything to this, so it will, this will be the answer. Okay, note it down. We have to, the function is given fx and there is some condition here, limit x tends to 1, fx minus 2 upon x square minus 1 equal to pi. And we have to find out the value of limit x tends to 1 fx, right? Now we have studied about the algebra of limits. If some fraction or quotient of functions is there, so we can take the limits separately. If addition and subtraction of the limits is there, so we can, function is there, we can also apply the limits separately. So first of all, we are doing that step, okay? What we are doing, we are taking the limits as limit x tends to 1 fx minus limit x tends to 1 2 upon limit x tends to 1 x square minus 1 equal to pi. Okay, now what we have to find out? We finally have to find out this value. Okay, so leaving it on left hand side, we are taking other values on right hand side. Limit x tends to 1 fx equals to pi. This will go in multiplication. Limit x tends to 1 x square minus 1. And this will go in addition. X tends to 1, 2. Now,
last में हम limit की जरूरत नहीं है, हम ऐसे खाली लिख सकते हैं.
If you can, but after you apply the limit here, because we are having this limit, you can write the value 2, because we know that limit of any constant function is that constant itself. So you can directly write 2 also, or you can just mention this or next step में लिख देंगे. Now here, what we can do to this, either we can write it as x minus 1, x plus 1, or you can put the limit here only. क्योंकि cancel तो होगा नहीं, so no need to simplify it as factors. So we can put x equal to 1 here. This becomes 0. And this is 2. So ये फिर से 0 plus 2, that is 2. So we get the limit as, and this is what we have to find out. Okay. Why have we not put the limit here directly? Because this will come as something upon 0. So it will become not defined. है ना? इसीलिए हमने यहाँ limit नहीं put करी. We first of all took it to right hand side. Okay. Because we don't need an indeterminate form. Note it down.
मैम हम 2 को पहले भी खोल सकते हैं, जैसे 2 के बाद पहले खोल सकते हैं या फिर सबको एक साथ खोलना पड़ेगा?
नहीं, इट्स नॉट नेसेसरी, पहले भी कर सकते हैं. हाँ, इनको भी अप्लाई कर सकते हैं. बट ये ध्यान रखना है बस इसकी लिमिट यहाँ डिनोमिनेटर में अप्लाई करनी है. Okay. Now let's come to the last question. Question number 32. Again, we are given a function fx equal to mx square plus n when x is less than 0. It is nx plus m when x is greater than equal to 0 and less than equal to 1. And nx cube plus m when x is greater than 1. So the function is defined like this. Now see here, when we look at the definition of the function, the function is defined with respect to 2 points, right? One is when x is less than 0, greater than 0 and equal to 0. And second point is when x is less than 1, equal to 1 and greater than 1. Okay? We have to find out both the limits. For what integers m and n does limit x tends to 0 fx and limit x tends to 1 fx exist? That means we are given 2 questions in this. First of all, we have to check for x tends to 0 that if limit x tends to 0 exists for the given function, then what are the possible values of m and n? And if limit x tends to 1 fx exists for the function, then what are the values of m and n? Okay, so it is given that the limit exists. Look at the question. For what integers m and n does these limits exist? Okay, so it is given that the limit exists. And what do we mean by this? That when limit exists, then yes, good. It is left hand limit equal to right hand limit for both the cases. And we have to find out m and n. for what values of, for what integers m and n. ठीक है, so we are taking the first case. Since limit x tends to 0 fx exists, therefore, yeah, we can say this implies left hand limit equal to right. Okay, left hand limit means limit x tends to 0 minus, first of all we are checking for 0, fx equal to limit x tends to 0 plus fx. And next step is we change the variable. Limit x tends to 0, f 0 minus h, very good. And limit x tends to 0, 0 plus h. Now let's look at the function 0 minus, that is less than 0. For less than 0, the function is, yes, m into, we have limit h tends to 0, m into x के place पे we will get 0 minus h whole square plus n equal to limit h tends to 0. Now it is 0 plus h. Plus means जो भी function 0 से plus के लिए greater than 0 के लिए define है, that is nx plus n, n into 0 plus h plus n. Okay. Now m and n limit तो हम put कर देंगे, h तो खत्म हो जाएगा, ठीक है. We have got m and n. We have to find out that for what integers m and n does this limit exist. Can we find out m and n from here? बस इतना ही आएगा, है ना. We cannot find out particular values of m and n because we are having only one equation and two variables, है ना. So we cannot find out particular values. We can get a relation from here that for all values when m is equal to n, then the limit exists. हाँ, सारी equal values के लिए limit will exist, ठीक है. बट कोई particular value नहीं आएगी. It will be in terms of, ये इनको क्या कहते हैं? We don't say them as variable. We have a particular name for this. Variable is x, है ना. Variable is x, जिसको हम limit x tends to, जिस terms में function given है, वो variable है. But m and n are not variable. They are constants. But we don't know the value of such constants. ऐसे constants को एक particular नाम है. What is that name? No, not extraordinary. Yes, anyone? We have a particular name. Those constants whose value we cannot find out, yeah, we don't know the value. They can have any value. Arbitrary constants. ठीक है? They are termed as arbitrary constants. M and n are arbitrary constants. नहीं, किसी चैप्टर में नहीं पढ़ा. This is general, right? So wherever you get such type of constants, they are arbitrary constants. Arbitrary मतलब कुछ भी. They can have any value. Yes. हाँ, बिल्कुल. ठीक है? So if we solve this, we get n equals to n. So we can say, so for all equal values of m and n, limit x tends to 0 fx.
तो जैसे कि हम मैथ्स में इक्वेशन में हम इम्प्लाइज यूज करते हैं, उसमें इम्प्लाइज की जरूरत नहीं है. जैसे कि हर बार जैसे आपने इम्प्लाइज लगाया LHN पे, उसके बाद इम्प्लाइज लगाया.
इम्प्लाई नहीं, उसके बाद क्यों लगाएंगे? उसके बाद तो ये कंडीशन हमें पुट कर दी. We have calculated, we know that this limit is this. Implies means when from this condition we are getting to this result. When using a condition we are getting to some result, then we say implies, right? And left hand limit, ये left hand limit का formula है ना? We just have applied that, so we are not coming to some result from here.
लास्ट में अप्लाई करेंगे.
नहीं, there is no need. Implies we only apply there whenever we are using some condition, and using that we are coming to some result. Okay. उसके बाद तो all calculative part is going on, तो implies की जरूरत नहीं है. And finally, we get this result that for all equal values of m and n, limit x tends to 0 fx exists. This was the first part of the question. Any problem with this? Yes or no?
No. No.
We are having a lot of space in front also. Friends, you can come and sit here. Let's come to the second part of the question, where we have to check for the values of m and n when limit x tends to 1 fx exists. Now the second part is limit x tends to 1. Again, we are getting to the same condition that when limit, because we are given that the limit exists, we have to find out for what values of m and n the limit exists, right? So if we take limit x tends to 1 fx exists, again left hand limit equal to right hand limit. Let's apply the formula. Left hand limit means limit x tends to 1 minus fx. Right hand limit is limit x tends to 1 plus fx. Now we change the variable because we cannot apply 1 minus and 1 plus. Changing the variable is always to h. So limit h tends to 0 or h हमेशा 0 को tend करेगा, right? क्यों? No one asked this question. Why will h always tend to 0?
तो some 0 tend करेगा. जैसे कि पॉइंट की वैल्यू होती है 0.0001 तो हम उसे मान लेते हैं पूरा ही है.
अच्छा, ठीक है. This
उसे
is
tend करेगा ऐसा कुछ लेते हैं.
ऐसे. Okay.
ज़्यादा डिस्टेंस.
Okay. Can calculatively we can we come to this result h tends to 0? Let me write the complete statement. It is f1 minus h. Then you just tell me why are we getting always h tends to 0? यहाँ पे कुछ भी हो, if it was 0 minus 0 plus or it was 1 minus or it may be 2 minus 3 minus 4 minus whatever point, at whatever point we are checking, h always tends to 0. Why? मतलब अभी पूरी तरह समझ में आया है.
b है, very small difference.
ओके. और कुछ?
मैं यही पढ़ा फिजिक्स में यही पढ़ा.
Anyone else? Rachit? ये विजय? विशाल? ये क्या है? Look at me. What is this? See what we are doing. We are putting, you can understand it that way also. But one more thing I am telling you. In place of x, we are putting 1 minus h. Yes? In place of x, we are putting 1 minus h. In place of x, we are putting 1 minus h. What x tends to? 1. Finally, it was what limit we are finding out? X tends to 1. Let's put x equal to 1 here. What do we get h as?
0.
So we get h as 0. Okay? You can understand it this way also.
Yes.
H is a very small value, so it always tends to 0. That is a correct concept. And we can understand it this way also, that whatever value we are tending to, whatever value x is tending to, so we are putting in place of x, we are putting that minus. And similarly here on right hand side, we are putting x equal to 1 plus h. right? We on right hand side we are putting x equal to 1 plus h. X tends to 1. Let's put x equal to 1 here. What do we get as the value of h?
0.
We again get the value of h as 0. Okay? So calculatively, if we want to get to this result, we can get it this way. Or h is a very small value. It always will tend to 0. There is a very small difference. We can get to that concept this way. Okay? कोई भी point हो. If it is 2 here, so we will put 2 minus h and 2 plus h. And x tends to 2, again h will tend to 0. So h will always tend to 0. So you can just note it down on right hand side of your copy. Okay, now f of 1 minus h. 1 minus h means the function, yes, which is defined for less than 1. 1 में से कुछ value minus हो रही है. So the function which is defined for less than 1. That means this one. Limit h tends to 0 and 1 minus h plus m equal to limit h tends to 0, 1 plus. 1 plus means 1 se bada. The function which is defined for greater than 1. Yes. And 1 plus h whole cube plus m. Okay. Let's apply the limits. So if we apply the limit, what do we get?
LHS is equal to RHS.
N plus m equal to n plus m. What does this mean?
Equal. वो मतलब वो
फाइनल हाँ एग्जिस्ट कर रहा है फाइनल रिजल्ट क्या आएगा इनफाइनाइट तो नहीं आ रहा है ना व्हाट विल बी द फॉर व्हाट वैल्यूज ऑफ m and n does this limit exist
addition of m and n in LHS
m और n की क्या वैल्यू यहाँ रख सकते हैं जिससे कि लिमिट एग्जिस्ट करे
कोई भी वैल्यू
कोई this is the answer this is the answer for any value of m and n right हाँ तो एडिशन तो कुछ भी आए उसका सेम ही आएगा हमेशा तो we can put any value of m and n for the limit to x whenever we are coming to some result हम अपने आप से हमें क्वेश्चन पूछ लेना चाहिए कि क्या वैल्यू रख सकते हैं हमें क्वेश्चन क्या लिखना था रिजल्ट क्या फाइंड आउट करना था कि फॉर व्हाट वैल्यूज ऑफ m and n तो ये किस कौन सी वैल्यूज के लिए डिफाइंड है सारी ही वैल्यूज के लिए डिफाइंड है राइट सो लिमिट x tends to 1 fx exists for all values of m and n okay any problem in this
no
note it down and here we complete with limits
हमें थोड़ा वैसे चैप्टर है जैसे 10th क्लास में चैप्टर 1 था
हाँ थोड़ा कॉन्सेप्ट बेस्ड है राइट थियोरेटिकल टाइप कॉन्सेप्ट
थोड़े से बैठो
मतलब मैं इतनी देर से समझा रही हूँ कुछ समझ में नहीं आया रट लो
मैम जैसे वो तो रटने पड़ेगा ना लिमिट x tends to 1 minus fx
okay that is the formula formulas you always have to learn right so here we complete with limits and tomorrow we will be starting with derivatives okay and if you have some problem you just revise this if any problem is there we'll discuss your problems and